Raheem goes to a grocery store and spends $22 to purchase 3 cartons of strawberries and 2 cartons of raspberries. Paul goes to the same grocery store and spends $41 to purchase 4 cartons of strawberries and 5 cartons of raspberries. What is the price of 1 carton of strawberries and 1 carton of raspberries? If we assign S to the price of the strawberries and R to the price of the raspberries, then the relation for Raheem's groceries is 3S plus 2R equals 22. Paul's groceries is represented by the relation 4S plus 5R equals 41. So far, we know 2 ways to solve the system of equations. We could graph each line and read off the intersection point, or we could use substitution. Now, graphing these lines isn't optimal since they have fractional y-intercepts. Using substitution isn't that great either, since you'll get fractional coefficients no matter what variable you solve for. What we need is a third method that will let us solve this without being burdened by fractions. The method of elimination is what we'll use to solve this problem. Given a system of equations, use multiplication or division to match coefficients so a variable can be cancelled out. In our equations, let's try and match the coefficients for r. You could have just as easily picked s, but we'll use r in this example. The coefficients 2 and 5 have a lowest common multiple of 10. Multiply both sides of the first equation by 5 so the r coefficient becomes 10. Now multiply both sides of the second equation by 2 so the r coefficient becomes 10 here as well. Simplifying, we get the equations shown here. This is looking pretty good. We have the same coefficient for r, but what do we do now? We must either add or subtract to get rid of r. In this case, we'll subtract. (15s minus 8s is 7s, 10r minus 10r is 0, and 110 minus 82 is 28. We now have the equation 7s equals 28. Divide both sides by 7 to get s equals 4. Now that we have one variable, we can get the other variable by plugging s into one of the original equations. If we plug in 4 for s in the first equation, we'll get r equals 5. If we tried using the other equation, we get the same result. The price of 1 carton of strawberries is $4, and the price of the raspberries is $5. You have now learned 3 techniques for solving systems of equations. You can graphically locate the point of intersection, algebraically solve with substitution, or algebraically solve using elimination. For the rest of the lesson, we will solve the examples using elimination, but keep in mind that all of them could be solved graphically or with substitution as well.